Okay, the third method has to do with limits involving infinity. Okay, take a look. The first types of problems we looked at, we were given like actual numbers that x is trying to approach, right? Like this one right there, x was trying to go to 4, so we plugged in 4. This one, x was trying to go to 3, so we plugged in 3. But like later on, this one, we're trying to find x going to 5, -3. So we were given numbers, and sometimes direct substitution worked, or we had to factor and simplify. But take a look at these ones. Oh my, where is x going this time? X is going to positive infinity. So you cannot really plug in infinity and write something like this. No, we're not going to be able to plug in infinity. Nope, we're not going to do that. So, if you have limits involving infinity, I wanted to give you a third method to find the limit, okay? But before I do that, I want to explain something that we will be using, okay? Now, imagine, take a look at this theorem right here that we'll be using. K can be any number. But what if I tell you to divide, let's say, a random number k, like 5? What happens if you do 5 divided by 100? Like dividing $5 to 100 people. They will each get how much money? Like 5 cents, right? What if I ask you to divide 5 by 1,000? They will each get 0.005, right? So imagine dividing by a really, really, really big number. Like I can go to 10,000. I'll just have one more zero there. But as you divide by a bigger and bigger and bigger number, like I'm gonna stop, okay? But you see we are approaching what number? We're getting smaller and smaller, and we are approaching 0, okay? So if you have a fraction and if you're dividing by a really big number, okay? Really big number like positive infinity or negative infinity, this whole fraction is going to 0. That's what you will need to remember, okay? That's what you will have to remember, okay? So, if you were to memorize one thing, it's this one right here, okay? So, anytime you have a number over x, any number over x, and the limit is telling you to go to positive or negative infinity, that's going to be automatically 0, okay? Because you're looking at a fraction that has a really big bottom, okay? Dividing something by a large number will be close to 0, okay? So, knowing that, I'll show you how to do these. The trick is, the method is to divide every single term by the biggest exponent in the bottom of the fraction. I hope I'm making sense. If not, I'll show you. Okay, I'll show you an example. Look at the bottom of the fraction. What is the biggest exponent here? It doesn't have it, but the highest degree is x to the first power, right? So what we are going to do is we're going to divide every term. And what I mean by every term is this 2x, this 5. There are 4 things going on. I shouldn't say term, but see there are 4 thingies here, right? Red, orange, green, and blue. I'm dividing all of these by x. So take a look. This is what's going to happen. Keep writing this limit notation. Limit as x approaches infinity. But now, you're going to divide everything by x. So I'll write that down. That's my plan for right now. Divide everything. Oh, whoopsies. Sorry, my tablet just freaked out for a second. Divide everything by x. Okay? And if you're wondering, why are you dividing by x? Because x had the biggest exponent in the bottom of the fraction. Now look, if I had x squared in the bottom, then I would have divided by x squared. Take a look at this one real quick. I'm going to divide this problem by x squared. I'm going to divide everything by x squared. What about this one? Oh, look. I'm going to divide every term by x to the third power because that's the biggest exponent in the bottom of the fraction. What about this one? Well, not the same anymore. All right, I'm going to come back up here and show you how I'm going to write this, okay? So we had that original big fraction bar, but now the first thing on top of the fraction is 2x. Look at this red, right? Divided by what? X. Now what's next? We had 5 there after it, right? So write down 5 divided by what? X. Go to the bottom of the fraction. We used to have 5x, but now that guy is getting divided by x, right? Almost done. Minus, we used to have that -1 there, but now that's going to get divided by x. Okay, so everything is getting divided by x. I'm going to now simplify this, okay? Let me keep on writing this limit. We're not done evaluating it, so you need to keep on writing this. Now, if you look at the top of the fraction, look at the red, okay? 2x divided by x is 2 plus, the orange cannot be simplified any further, 5 over x, right? But the green in the bottom, that can be simplified. 5x divided by x is 5. And then what about the blue? That's still 1 over x. That cannot be simplified. But remember what I said. Remember what we said. That anytime we have a limit form that has a number on top and x in the bottom of the fraction, that's equal to what? 0. So I'm going to highlight those with the gray highlighter, okay? So this 5 over x, this 1 over x, okay? Those two gray highlighted things are going to 0. Okay, so here's my final answer. My final answer is 2 plus 0 on top and 5 minus 0 in the bottom. And that simplifies to 2 over 5. And that is how you can, algebraically find the limit of an expression that's approaching positive infinity, okay? You probably remember from pre-calculus that the horizontal asymptote is just reading the ratio of leading coefficients. And you see that right there, 2 over 5. But that's not always going to work if the degree of the numerator and the degree of the denominators are different. So let's try another practice problem here, okay? This one. So I'm going to divide everything by what number? What term? X squared. Because that's the biggest exponent in the bottom of the fraction, okay? In the denominator. So that's what? Limit as x approaches positive infinity of, I have to make it big. All right, the first term used to be, it used to be 4x. I have to say 4x divided by x squared. Next, minus 5. Well, that's going to be, minus 5 over x squared. Okay, let's go to the bottom of the fraction. 2x squared will turn into 2x squared minus, over x squared. Keep going. I need a plus sign. And what's next? There used to be x. So I'm going to say x over x squared. And lastly, plus, it was what? Just 1. So I'll say 1 over x squared. So on your first exam, I do want you to show me that, what you are dividing by. And the next line has to be what you get when you simplify this expression. Okay, let's simplify. What happened to the red one? You have one more x in the bottom of the fraction. So you will get 4 over x, right? The red turned into 4 over x minus. I don't think I can simplify this any further. Nope. So I'm just going to copy this down. All right. What about this green one in the bottom? 2x squared divided by x squared. That's going to be 2. And then I will have plus. Now look at the blue one for me. you have x divided by x squared. The bottom has one more x, so this will turn into 1 over x. And the purple one cannot be simplified any further, so I'm just going to copy this down. All right, let's see. Anytime you have a number on top and x or its cousins like x squared or x cubed, that fraction is going to 0. So I'm going to highlight every fraction that's going to 0. This is going to 0, right? That's 4 over x. This is going to 0 because that's 5 over x squared. Okay. This is going to 0 because that's 1 over x. And that's also going to 0. Anytime you have x in the bottom of the fraction, and just a number on top, those gray things are going straight to 0. So what do I have left? This is equal to 0 minus 0 from the red and the orange. And the bottom I have 2 plus, the green survived, right? But the blue and the purple are gone. So I have this. Well, that's just really 0 over 2. And unfortunately, everything canceled out. And it's just 0. So the limit of this expression is actually 0. And if you graph this, you will see a horizontal asymptote at y equals 0. Whenever the degree of the denominator is bigger than the degree of the numerator, that's what's going to happen. We'll automatically have a horizontal asymptote at y equals 0. And it's because the bottom is getting bigger quicker. Okay? So you have a small number and much bigger number dividing, and that's approaching 0, okay?